Hey, good morning, everybody. This is Mr. Ainsworth at Great Oak High School here. We are going to get into lesson 4 here, talking about exponential and geometric sequences and their applications. All right, we did a little bit of this in, excuse me, in section 3, and we're going to do a lot more here in section 4. So let's get right into it. It's calculator active. Get your 284 out or Desmos, whatever you want to use. All right, because when you deal with exponential functions, you need it. Okay, here we go. Let's get right into it. The number of students enrolled at a certain university increases 4% per year. Okay, well, guess what? That's important. In 2020, the university has 24,268 students enrolled. Okay, write an equation for a function n where n of t models the number of enrolled students per year, where t is the years since 2020. Okay, so that's important too. All right, so t is the number of years 2020. All right, so what that means is that the initial year, this is at t equals 0 here. All right, so if you want to think sequences here, a sub 0, initial time at 2020, a sub 0 is 24,268. That's our initial value. Okay, now when you're using geometric sequence formula, if you're going to use this, okay, it'd be a sub n is equal to a sub 0 times r to the nth power. Okay, if you want to write it as a function, all right, y is equal to a times b to the power of x, or you can use function notation if you like, or n of t actually. So n of t is equal to a times b to the t power. All right, so you have to use, the correct functions or sequence formula for this model. Now, if it increases 4% per year, their common ratio is greater than 1. All right, so let's talk about that, your common ratio. So your growth factor, okay, common ratio, that's R. So R is greater than 1. So 100% plus the growth of 4% each year, so it increases. All right, so R is greater than 1. So 104%, so R is 104%. As a decimal, R is 1.04. That's your growth factor. It's your growth rate, actually. It stands for growth rate. In sequence formula or in sequence jargon, it's common ratio, but it's greater than 1, so it's growth. Okay, so let's write the function. So if in sequence notation here, it'd be a sub n, or in a function, it says n of t, so n of t as a function of time, it'd be your initial value, 24,268, times your growth rate, or your common ratio here, 1.04, to the t power, okay, to the t power. Okay, if you want to, in sequence notation, it would look like a sub n, all right, is equal to 24,268 times 1.04 to the nth power. Okay, now it's not n minus 1 because we're referencing a sub 0. You could write it up there, n minus 0, but that'd be kind of silly. Okay, if you want to write it in respect to 2021, that'd be to the n minus 1 power. But we don't know a sub 1 year after 2020. We haven't calculated that yet. Okay, and there we go. So that's simple. So it's an increase of 4% per year. So our growth rate, our common ratio is 1.04, coming from 104%. And whenever it's greater than 1, things increase over time. When it's less than 1, it decreases over time. All right, number 2. Select the values of an exponential function are given in the table. Complete the rest of the table. Okay. So in terms of sequences, this would be n, and this would be a sub n. In terms of x and y values, we got x values from 0 to 5, or y values when x is 2, y is 9, when x is 3, y is 15. All right, and then what are these values? Now it's exponential, which means it's geometric. So remember that. So let me write that down. So exponential function means that it's geometric. which means we have to find common ratio. Find common ratio, which is called R. Okay, so R is equal to, and it's always equal to A2 divided by A1, but we're not given those. We're given A sub 2, we're given A sub 3, and we're given A sub 2. So A3 divided by A sub 2, third term divided by the second term, it's that simple. All right, and you take 15 divided by 9, and you simplify it in the ratio. So they're both divisible by 3. That's 5/3, right? 5/3. There's your common ratio. And notice it's greater than 1, so this is growth. Okay? 1 and 2/3 is greater than 1. And notice the sequence is increasing. So it's got to be increasing. It's got to be growth. All right. So what we want to do is we want to multiply by 5/3 to get the next term. So we multiply by 5/3. This is the concept. All right, and then we take 15 times 5/3. Okay, you can multiply and then divide, but if you want to do without a calculator, you divide first, get 5. 5 times 5 is 25, and then voila, this is 25. And again, multiply by 5/3. That's the concept. So we take 25 times 5/3, and again, learn how to use your TI 1000 inside your head. And this right here, 25 is not divisible by 3, so just multiply 25 times 5, which is 125, divided by 3, and just keep it improper, okay? Don't waste your time making it a mixed number, okay? In this class, once you get, in pre-calc and above, the instructors don't care whether you leave it improper or fractional, okay? It's no big deal. Now, if you want to go backwards in the sequence here, you got to do the inverse, right? Which is called division. So you divide by 5/3, okay? Or you multiply by 3/5. Okay, so here you want to take 9 times 3/5. Divided by 5/3 is the same as multiplying by its reciprocal. So what we need to do is take 9 times 3/5, which is 27/5. So that's 27/5. Like I said, keep it improper, make it easy for you. And then you multiply that by 3/5. So 27/5 times 3/5 is 81/25. Excuse me. So 81/25. All right. And again, you just keep working backwards. Okay. You can either divide by 5/3 or multiply by 3/5, the reciprocal. Let's see here. Watch this. So 27/5, 27 divided by 5. All right, times 3/5, 3 divided by 5. You get a decimal there, but make it a fraction. Okay, 81/25. So decimals here can change it from decimal to fraction. But you're in pre-calc, you should know how to do this in your head. Okay. All right, there we go. Next one here, an exponential function of the form y equals a times b to the x, okay, passes through these 2 points, find the values of a and b. There are different ways to do this. I'll do the sequence formula first. So this here is the second term, so this is n comma a sub n, okay, if you want to think of it as in sequences. So we're given the second term is 27. We're given the fourth term is 3. So interpret. They look like ordered pairs, right? And you can think of it as, x and y ordered pairs. Or you can think of it as terms in the sequence. All right, these are terms, all right, in the sequence. All right, given the second term and the fourth term. Now it's exponential, so you have to think geometric. Okay, keep that in mind. Anytime you see the exponential, think geometric. Every time you see geometric, think exponential. All right, which means we have to find the common ratio. So one way to conceptualize it is this. We know the second term is 27. We don't know the third term, but we know the fourth term. We know the fourth term is 3, and guess what? It's decreasing. So sequence is decreasing. That means that r has to be less than 1. Okay, of course, this is what you're thinking. Okay, So if a sequence is increasing, the common ratio is greater than 1, but it's less than 1, so it's got to be a fraction, right? So what do you do from 27 to 3? And then hopefully it's pretty obvious, from, what do you multiply 27 by to get to the third term, and then multiply it by the same number to get to the 3. So what do you multiply? And again, it's a fraction, right? So times r times r. 27 times the ratio, fraction times the same fraction gives you 3. And everybody knows that 27 divided by 3 is 9. 9 divided by 3 is 3. So, but if you divide by 3, that's the same thing as multiplying by 1/3. So you can do it, in your head on this one because it's fairly simple. So I know the common ratio is 1/3 because it was simple, but sometimes it's not. So let's talk about strategy here. All right, strategy. Because most of the time it's not simple. So 27 times r it's got to be equal to 3. And that gives you 27 times r squared equals 3, right? And then you divide by 27, simplify, you get r squared equals 1/9. And then, of course, you square root this puppy. And so you square root here, and you get r is equal to 1/3, and this is called a common ratio. Okay, and that's the basic way to handle this situation right through here. There is another way to do it too, using systems of equations, and you can do it that way. Or, you know what? Let's use a sequence formula. You know what? Let's do that. So let's switch gears. So I've been talking about this a lot in class. So let's talk about method 2 here. All right, using sequences. Okay, so a sub n is equal to a sub 1 times r to the n minus 1, but we don't know the first one here, so let's use another version of it, a sub 2 times r to the n minus 2. So check this out. We know r is equal to 1/3, so a sub n is equal to a2, which is 27. Okay, the second term of the sequence is 27, just look up top, right, times 1/3 to the power of n minus 2. And the question is that the same? Oh, wait a minute. I didn't even write the function earlier. Haha. Oh, so I thought I was done, and I'm not done. I'm being silly right now. So it's my second video this morning, so sorry, guys. So we got to simplify this. Well, I mean, you're done there, but let's go ahead and simplify it. And let's see if it makes sense of it. So 27 times 1/3 to the nth power times 1/3 to the negative 2 power. Okay, so what is that? 27 times 1/3 to the nth. Now, when you take a fraction to the negative 2 power, you have to reciprocate it and then square it. The negative reciprocates it, meaning inverts it, okay? So the reciprocal of 1/3 is 3, but then you got to square it, and you get 9, okay? 9, look at this. Okay, if you don't know what this is in your head, so you take 1 divided by 3. Like I said, I'm just verifying. You shouldn't need a calculator. You should be able to do this in your head. So again, the negative power reciprocates the fraction to 3, and then you got to square it to get 9. Okay, and then 9 times 27, so 9 times 27 is 243, and so 243 times 1/3 to the nth power. Okay, and then so if you compare here, compare this here, this a times b to the x power. So that tells you that a is 243. That's your initial, that's a sub 0, by the way, 243, a sub 0. And b is 1/3. B is 1/3. That's the same thing as a common ratio. Okay, now let's see if that makes sense. So let's go backwards in time. So let's go backwards in time. So here we go. Take a look at what we have up here. And we don't know a sub 0, so let's find it, okay? A sub 1, if you multiply by 1/3 to the right, you divide by 1/3 to the left. which means if you divide by 1/3, you're multiplying it by 3. All right, and 27 times 3, so times 3 here is 81. And then if you do it again to get to a sub 0, you multiply it by 3. All right, here you get 243, and that's a sub 0. So if you put it all together here, uh, there you go. You find your common ratio, and then you write the sequence formula, and then you simplify it. All right, simplify using exponent rules. That you learn in Algebra 1, okay, and Algebra 2. Actually, you learn them all in Algebra 1. I teach all this stuff to my ninth graders, okay? And then you compare it, all right, to y equals, right here, y equals a times b to the x power. It says find the value of a and b, and there you go, all right? Pretty cool, all right. All right, now let's keep it going here. We have a few more to do. I'll do a few more. Uh, the next one here. So four, a company emails its initial weekly newsletter to 54 people. Guess what? There's a sub 0. See, you have to interpret what you're given in terms of like in the context, but interpret it mathematically. It says initial. All right. That's always when n or x equals 0. So a sub 0 is 54. All right, 2 weeks after the launch, the company emails a weekly newsletter to 64 people. Well, guess what? 2 weeks, a sub 2 is equal to 64. So you're given the initial and you're given something 2 weeks later. So you have to interpret it as you go, okay? Or you can write it in terms of ordered pairs. You can write it as 0, comma 54, right? And 2, comma 64. So however you want to write your information and organize it, you could write it in as terms. These are terms in the sequence. Okay, using sequence notation, or you can write it as ordered pairs, or however you want to think about it. Now, part A says assume that the number of people receiving the newsletter increases in a linear fashion. All right, a linear fashion. Well, that's equals y equals mx plus b, or a sub n equals a sub 1 plus d times n minus 1, or if you want to use your initial value, a sub 0 plus d times n. All right, this is using the initial value. You might want to use that one because guess what? We know what it is. All right, find RT, the number of people receiving the newsletter 2 weeks after launch. So we'll write it in regular notation, and then we'll switch it to this function notation, which is what they're asking for. Okay, so here we go. Let's use sequence notation first. Actually, we need to know the rate of change. So D is equal to the average rate of change. So that's, we're given the second term. So A sub 2 minus A sub 0 divided by 2 minus 0. So that's 64 minus 54 divided by 2. All right, 10 minus 10 divided by 2 is usually 5, so D is 5. Okay, then here we go. So let's use a sub 0, 54, plus D times n, and there's your linear function in terms of sequence notation. But they want you to write it in function notation, R of t, where t is the number of weeks in launch. Okay, so let's do that. So here, R of t is equal to 54 plus 5 times t. This is function notation. And this right here is sequence notation. All right, now they want you to change gears, and they want to assume now it increases exponentially. Ooh, write a function n of t that represents the number of people receiving the newsletter 2 weeks after launch. All right, so now we have to think differently. So a sub 0 is 54. We don't know a sub 1, and we know a sub 2 is 64. All right, and then we have to think, what is the common ratio here? Okay, so we have to change our mindset. We got to find the common ratio. Okay, so let's do it. Let's do it. Okay, 54, all right, times R is equal to 64. That gives you 54 times r squared equals 64. All right, divide by 54, you get 64 divided by 54. And this is where the calculator comes in. All right, uh, that is tough to do in your head, so you have to square root it. And again, this is a calculator question. So you take the square root of the fraction 64 divided by 54, and you round it 1.08 0.0887. 7. Okay, so 1.0887. There you go, three significant digits. All right, and notice it's greater than 1, so it's growth, which makes sense. It goes from 54 to 64. All right, now it says write the function. So here we go. So n of t now. Again, n of t is equal to, let's see, we're given a sub 0, so 54 times 1.00, excuse me, that's not correct, 1.0887 to the t power. All right, and we don't subtract anything from it because we're using the initial value. And that's it. And if you want to see if it works, you can check, substitute 2 in. All right, you better get 64. So let's check. N of 2, so n of 2 is equal to 54 times 1.0887. It won't be exact because we're rounding this common ratio. Excuse me, can't speak. All right, so let's see what we get. Let's just double check it. So 54 times 1.0887, raise that to the second power. And notice you get 64.004, which is close to 64. So 64.004, which is obviously that number there. And the reason why we have this little error, this is a little error here, is because we rounded the common ratio. It's an infinite decimal. Let me just look at it. It's on the screen. 1.088662109. If we used all those digits, we'd get a lot closer. Okay. All right. Let's take a look at this one here. It's kind of a cool problem, number 5. Amount of Sudafed in milligrams remaining in the adult bloodstream after taking one dose can be modeled by this function. Ooh, look at that. It's an exponential function, where t is the time in hours since taking the Sudafed. All right, and notice that the common ratio is less than 1. Okay, so less than 1. So it's a decay. So it decreases over time. So it decreases over time. So how many milligrams of Sudafed are in one adult dose? Okay. Well, let's interpret this. So that's in the beginning. We got to find the initial value. All right. So initial value a sub 0, the initial value. When does that occur? Well, it occurs when t equals 0. So you got to evaluate the function at 0. So p of 0 is equal to 340 times 0.65 to the 0 power. And we know that this right here is 1. Anything to the 0 power is 1. So we get 340 milligrams. Okay, the initial value. Okay, what percent of the Sudafed? What percent of the Sudafed is eliminated each decrease? So what is the percent decrease? What is that? Well, if you look at the function here, p of t is equal to 340 times 0.65. Oops, come on, Ainsworth. To the t power. This right here represents the ratio here is 65% remaining. Okay, we've done this before. That number there, that 0.65, your common ratio, R, represents the percentage remaining. And if you have 65% remaining, okay, that implies if you take 100% minus the 65%, you get a 35% decrease. And that's the answer to your question. It says what percent of Sudafed is eliminated? Keyword eliminated here. Okay, and so, well, 35% is eliminated. You take the percent remaining, subtract it from 100, and you get the decreased amount. All right. And that's it. All right, number 6, last one. Allie drinks an 8-ounce cup of coffee that has 124 milligrams of caffeine in it. Okay, guess what? That's your initial value. There. 1 hour later, she has approximately 108.2 milligrams caffeine left in her body. The amount of caffeine in her bloodstream changes by a constant factor each hour. Okay, does this situation model exponential growth or decay? Well, if you're going from 124 to 128, so 124 milligrams to 108.2 milligrams, okay, that is a decay situation, okay, because it's decreasing over time, okay, decreasing over time. What percent of the caffeine remains? What percentage? Percentage remaining. So percentage remaining over time. What is that? Well, you got to take a2 and divide it by a1. So always the second term divided by the previous term. So that's 108.2 divided by 124. And then once again, use your calculator here. That's why you always should be split screen or have your TI-84 next to you. So you can actually do the calculations real easily like I'm showing here. Okay, and that's 0.873, 0.873 round to the nearest. Actually, let's take 4 digits because I have to change it to a percentage. So 0.8725 or 26. So 26, and that's 87.26%. Okay, remaining. All right, we can value the decrease too. We can subtract from 100 to get the decrease if we wanted to, but it's not asked right now. It says write the function C of t. Okay, C function, C for caffeine, right? So this is a caffeine function. So C is caffeine over time, C of t. So C of t, again, this is caffeine function. And then t equals time and hours, after the initial dose. Okay, and then so the initial value, it's a sub 0 times r to the, to some t power. So what do we have? We initially have 124 milligrams. Our percent remaining, or our common factor, this is the common ratio, by the way, is 0.8726, and you raise that to the t power, okay? Or, you could use your 108.2. So if you want to rewrite it, you could write it in respect to the 1 hour later, which is a sub 1, right? So if you do that, a1 times r to the t minus 1, or 108.2, gotta write that, 108.2 times your common factor here, so common ratio, right, to the t minus 1. Okay, so you can write it different ways. If you simplify the second function, you'll get the first function. All right, do it on your own. Check that out. That's what happens. Okay, and there you go. That is the application, okay, of your exponential functions and geometric sequences in action. All right, so this is Mr. Ainsworth here. I'll see you in class. Make yourself proud and work hard. Study it, practice it, do your homework that's attached, and do your best. Okay? Take care, guys. I'll see you in class.